Hey guys, Mr. B here, bringing another math video. In this video I'm going to take you through solving two different types of log equations, and I really want you guys to sort of focus in on why these are different. So if you look at this equation right here, I have a log minus another log is equal to a number. So this what makes this one kind of different is that you have a number out here all by itself. So first of all, we have to use our rules of logs here to be able to simplify this. So when you're subtracting logs with the same base, you divide what's inside the log function. So this guy becomes log 64, and then big brackets, x squared plus 3 all over x plus 2, and that equals 1 over 3. So we reduce this using our rules of logs such that we have a log on one side and then another number on the other. This would be 1 over 3. So now the next step is to be able to solve this. So in order to solve a situation like this, a log equal to a number, we have to change to exponential form. So I always tell my students to start with the base here log. So the base of my log is the base of my exponential. The number that it equals is 1 over 3. Or the number that the exponent is the number that it equals. So log to the 1 over 3 is equal to what's inside the log function. So x squared plus 3 all over x plus 2. So this is essentially the same as cube root. So the cube root of 1 over 3 is 4. 4 times 4 times 4 is 64. And then that's still equal to x squared plus 3 all over x plus 2. So right here I'm going to cross multiply. So I end up with, so I'm going to distribute here because it'll be 4 times x plus 2, so it's going to be 4x plus 8. So I distribute it through with that 4 is equal to x squared plus 3. So now I have to use some simplification, and hopefully I'll be able to factor or use quad form. So I get 0, so I'm going to take everything on this side and just combine it with that. So I subtract 4x on both sides, so there's nothing to combine it with, so I just have x squared minus 4x. And then I subtract 8x from both sides, or 8 from both sides, so 3 subtract 8 is minus 5. So this will actually factor to x minus 5 x plus 1. So this is like the AN method. What adds to give us negative 4 and multiplies to give us negative 5. So negative 5 plus 1 is negative 4. Negative 5 times 1 is negative 5. You could also use quadratic formula there, guys. A lot of my students just automatically do it. Don't even think about it. So x is equal to 5 and negative 1. So those are my possible solutions. So what I had to do now is I have to just do a quick check to see if they'll work. So I go back up to and I sub my 5 in here. So 5 squared plus 3, that's a positive number. Remember, what's inside of here has to be greater than 0. Same with this one. This one has to be greater than 0. So both of these numbers are going to work because I have a squared there. The next thing I have to do, now messed me up here. Let me see. Pen's blue. So the next thing I have to do is check this guy. So 5 plus 2 is greater than 0, 7. And then negative 1 plus 2. Yep, so we're good to go on both fronts. So my solution to this guy is x is equal to 5 and negative 1. Alright, let's try the next one and contrast how it's different. So if I look at this one, I need to go ahead and solve this guy right here. So I have to use my rules of logs, and if you notice here there's no number by itself. I have logs on both sides of the equation. So again, I'm adding logs. So adding logs, I multiply, so I have log, and these are all base 10 because there's no number written here, so we have the same base. So it'll be 2x minus 7 times x minus 1, bracket. Same over here, we have, we're adding logs, so we multiply, so log x plus 1, x minus 7, just like that. So now the next scenario is, so the last one we changed to exponential form. In this one, we're going to use our fact that since we have logs on both sides of the equation, we only have one log on each side. We have a log equal to a log. We have the same base in both our logs. That means we can sort of eliminate our logs. In order for these things to be equal, what's inside of them has to be equal. So we essentially have this. So a lot of people think of it as like you cancel out the logs. That's not correct. Essentially what it is like if you have a situation where I have log question mark, so something must be in there, and then I have log is equal to log of question mark. In order for this to be true, since these logs are the same base, then what's inside of here must be the same. So these question marks must be the same thing. So these question marks are just slightly more complicated because they're quadratics. So now I have to do some FOIL and simplification. So first, 2x squared first outside, negative 2x inside, negative 7x, so that's negative 9x, and then last plus 7. And then first, x squared, outside, inside, so that's going to be minus 2x. And then last is minus 3. So hopefully I did that correct. I'm doing it kind of quick. So now I got to simplify, so I'm just going to take everything on this side and bring it over here. So I'm just going to over that way. So 2x squared, I'm going to subtract x squared from it, so I'm left with x squared. And then I have add 2x to both sides. I think that's 2x, yep. So add 2x, so it's going to be minus 7x. And then I'm going to add 3, so it's going to be plus 10 is equal to 0. So this guy is going to be, so when I factor adds, give me negative 7, multiplies, give me 10, so that's negative 2 and negative 5. So x minus 2, x minus 5 is equal to 0. So then I have x is equal to 2, x is equal to 5. So those are two possible solutions. Now I'm just going to do a quick check. So I can immediately see that this one is not going to be a solution. So if I go up here and sub it in here, 2 minus 3, that's negative 1. That's not a good number. It can't be in the domain of log. Logs have to be, what's inside has to be greater than 0. So we're going to reject this. And that's outside the domain. And then we could say check 5. So 5 works here. It's positive, 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 and then positive. So my solution is x is equal to 5. And there it is, guys. That's how you solve log equations. So I hope this helps you in your journey to be able to figure this stuff out. And thanks for watching. If you enjoyed this video, like, share, subscribe. I'll see you guys in class.